Welcome! In this explainer, we're going to dive into the essentials of data communication and networks. My goal here is to break everything down in a way that will really help you prepare for your exam, especially with the kinds of multiple choice questions you're likely to see.
We've got 5 key sections lined up. We'll start with the core concepts, then get into network types, the hardware that makes it all run, and of course, internet security. Then we'll wrap it all up with some practice questions to make sure you're feeling confident.
All right, let's kick things off with the absolute basics. Getting these 2 fundamental definitions right is really the key to understanding everything else we're going to cover today.
So think of data communication just like a simple phone call. For that call to be successful, 4 things have to be right. First, the message has to get to the right person. That's delivery. Second, it has to be understood clearly. That's accuracy. It also has to arrive when it's supposed to. That's timeliness. And finally, the conversation needs to flow smoothly without any strange pauses, and that's what we call avoiding jitter. It's the exact same for computers. So then what exactly is a network? Well, an easy way to think about it is like a team. All the members, or in this case devices, are connected so they can talk to each other and share resources. And the internet? That's just the biggest, most massive team on the planet. Okay, so we've got our core definitions down. Now let's explore how these networks are actually organized and built. In this section, we'll look at the different sizes and layouts you absolutely need to know. You'll generally hear about 4 main types of networks. The first 3, LAN, MAN, and WAN, are really all about geographical size. LAN is local, like in an office. MAN covers a whole city, and WAN is wide, covering a huge area like a country. The fourth one, SAM, is a bit different. Think of it more like a special private network that's just for connecting storage devices. This table right here is perfect for comparing LAN, MAN, and WAN. Now, for an MCQ exam, you'll want to pay really close attention to the area and example rows. Understanding that a LAN is for a single building, while a WAN can be the whole internet, that's a classic distinction they love to test.
Now let's talk about structure. In a client-server network, just picture a library. There's a central server, that's like the librarian, who holds all the information. You, the client, have to go ask the librarian for what you need. But in a peer-to-peer network, it's more like a book club. Everyone is equal, and you all share information directly with each other. There's no single librarian in charge.
Next up are network layouts, or as they're officially called, topologies. This is a huge topic for MCQs, so listen up. In a star network, everything connects to a central point, a hub. In a bus network, everything connects to one single main cable. The most important thing for your exam is knowing how each of these fails.
And here's that MCQ alert. This is a very common exam question, so you'll want to remember this. In a star network, if one computer's cable breaks, only that computer is affected. The rest of the network keeps working just fine. But if that central hub dies, the whole network is gone. For a bus network, it's all about that main cable. If it breaks anywhere, the entire network comes to a halt.
All right, let's move on and look at the actual physical parts that make these networks run. This is the hardware that's actually sending and directing all that data we've been talking about. This right here is a classic exam comparison, hub versus switch. A hub is, well, it's a dumb device. It's like someone shouting in a crowded room. Everyone hears the message even if it's not for them. This creates a lot of extra unnecessary noise. A switch, on the other hand, is smart. It's like a mail carrier who delivers a letter only to the specific address it's meant for. It makes the whole network way more efficient. Here are 3 other key pieces of hardware. A modem is basically a translator. It changes your computer's digital signals so they can travel over older analog lines. A router is like the traffic cop of the internet, directing data packets to make sure they get where they're going. And a gateway, think of it as a diplomat, allowing 2 totally different kinds of networks to communicate with each other. Okay, so now that we understand the structure and the hardware, let's talk about the biggest network of them all, the internet, and some of the security risks that, come along with that.
The World Wide Web, which most of us just call the web, is the system we use to access all that information online. It's all the websites, the pages, the text, images, and videos, all linked together. It's really the main way we navigate and use the internet today. And this brings us to the darker side of things. Cybercrime. It's a really broad term for any illegal activity that involves a computer, either as the tool to commit the crime or as the target of the attack.
Let's look at 3 serious threats. Cyber extortion is basically a digital shakedown demanding money to stop an attack.
Cyberterrorism uses those same kinds of attacks, but for political reasons. And then there's social engineering, which might be the most clever because it doesn't attack the technology, it attacks people, tricking them into giving away information.
We have covered a lot of ground. So now it's time to bring it all together, reinforce what we've learned, and run through some exam-style questions.
Okay, here's our first practice question. For two devices to be able to communicate successfully, what two components are absolutely essential? Just take a moment to think it through.
The correct answer is B, hardware and software. Here's why. You absolutely need the physical device itself, the hardware, and you need the programs that tell it what to do, the software. Option A is wrong because data is the thing being sent. It's not a core component of the device. And option C is just too vague. System isn't precise enough. It's always hardware and software working together.
For this next question, I want you to think back to those network layouts we discussed. Which one of them has that single central point of failure that can crash the entire network?
And the answer is C, star. Remember, in a star network, everything connects to that one central hub. So if that hub goes down, the whole network goes with it. Now, why are the others wrong? A bus network fails if the main cable breaks, not because of a hub. Mesh is designed to be tough. It has lots of connections, so a single failure isn't a disaster. And peer-to-peer isn't really a physical layout in the same way, and by definition, it doesn't have a central point.
All right, here's your final high-yield summary. Let's run through it one last time. Data communication needs both hardware and software. LAN is local, WAN is wide. A hub is dumb and shouts. A switch is smart and directs. When it comes to failures, a star fails at the hub and a bus fails at the cable. And finally, cybercrime is any illegal act involving a computer. If you know these 5 points, you are in excellent shape for your exam. And that brings us to the end. As a final thought, I want you to consider this. Of all the cyber threats we talked about, which one do you think is the hardest to protect against, and why? Thinking about that will really help connect these ideas to the real world. Thanks for joining this explainer, and good luck with your exam.